This is the third section of the hypothesis testing chapter, and now we look at hypothesis testing for the parameter P of a geometric distribution. Now, just like any hypothesis testing, we always need to set out what H0 is and what H1 is, so the null hypothesis and the alternate hypothesis, like this. And in the case of a geometric distribution, we're going to be setting out a null and alternate hypothesis, which represents the probability. Okay, so it's going to be the probability of something that has happened and whether that probability has changed or increased or decreased. So that's going to be a probability. So very similar to when we do a hypothesis test for a binomial distribution, where we look at the probability and we see whether the probability of proportion has changed. And just like the binomial, we need to work out what the probability of that outcome is. And here we've got some rules here that can help us work out the probability for a geometric distribution. Now remember, when we do our problems, so first thing you'd write down what H0 is. It's going to be the probability that P is equal to something. H1, alternate hypothesis, is going to be either that it's not equal to, or it's greater than, or it's less than. Then you're going to set out or write down that it's a geometric distribution, and you'll write down in here what your probability of success is. Now, the one big difference with this and any other distribution is that if we're looking for, let's say H1, is that we're looking to see if the probability has decreased. Now, when normally we would do a lower tail test when we're doing a decrease, but with a geometric distribution, we actually, when we're looking to test whether the probability is decreased, we do an upper tail test. Now, the reason we do that is because the mean of a geometric distribution is 1 over P, which means as P decreases, as this decreases, the mean increases, because it's the reciprocal. Now, with a binomial distribution, for example, if the probability decreases, the mean also decreases because you do n times p to work out the mean. It's the same with a Poisson distribution. As your proportion decreases, the mean increases because they're all the same value. So this is the big thing we need to be careful of, because as the probability increases, the mean decreases. So when we're looking for a decrease, we do an upper tail test. So the opposite will be true, H1. If P, looking for an increase, we do a lower tail test for the same reason. Yeah, because when the mean is 1 over P, so as P increases, here the opposite, it will mean that the mean decreases. So do watch out for that it's the opposite way around to what we've been used to with all the other hypothesis testing. Okay, got this example here. A company claims that 1 in 8 of their packets of crisps, so let's just highlight that, 1 in 8 of their packet of crisps contains a prize ticket. Lee decides to test this claim and buys a packet of crisps every day until he finds a prize ticket. Now, this is the clue that tells us that we're dealing with a geometric distribution. There's not a fixed number of trials here. He's buying crisps until he finds a prize ticket. Yeah, it's not like he buys a packet of crisps on 10 days and he wins one prize. That would be binomial. He's buying the crisps until he gets a prize ticket. So this is the clue that tells us that this is a geometric distribution. Okay, so we're doing it until we get success. Okay, so we are doing it, which is buying a crisp in this place, until we get success. So there is no fixed trials. Look for that. That's the clue that tells you it's a geometric distribution. Lee finds a prize ticket for the first time. So he finds a ticket for the first time on the 24th day. So we'll highlight that as well. Finds a ticket for the first time on the 24th day. Test at the, and here's our significance level, 5%. Whether there is any evidence to suggest the company is overstating the proportion of packets of crisps containing a prize. Right, so our first step in a question like this is to state H0 and H1. So H0 is going to be, well, that the probability of getting a prize is 1 in 8. Now, if they are overstating their claim, that means that actually we want to see whether the probability is less than an 8th. Yeah, not greater than an 8th. They're overstating. If they were understating, then we'd be looking for greater than an 8th. So it might be worth writing down that if we see the word overstating in a question, we're going to be doing something like that. And if it says understating, it's usually overstating, then we do this. So that might be worth not 0, just greater than. That might be worth writing down as a reminder for the wording in these questions. Then we need to state what our random variable x is. It's always good practice to do this. So what is he doing in this case? He's buying packets of crisps until he finds a prize. So x is going to be the number of packets of crisps bought until Lee, let's make this personalize this question, until Lee finds a prize ticket. Until Lee finds a prize ticket. So that's what x is going to be. So we know that this is a geometric distribution. So geo, and p is going to be 1/8. Okay, and let's state the significance level. So sig level is 5%, so we're going to be comparing probably to 0.05. Now remember, when we see the probability and we're testing to see if it's decreased like that, that means we do an upper tail test. So watch out for that. Remember, it's the opposite to how everything else is done, all the other hypothesis tests we've done. So it's upper tail test. So just remember that you don't do a lower tail test. So what that means is we want to find a probability that he has to buy more than or equal to 24 packets. Now we can just use the probability rule to work it out. We given this, so if you want to work out the probability that x is greater than or equal to x, that is 1 minus p to the power x minus 1. Okay, so all we need to do now is just plug the numbers into that. So it's going to be 1 minus p, which is an 1/8, to the power of x minus 1. So in this case, x is 24. So basically to the power 23. So let's work that out. So that's basically like 7/8 to the power of, so I'm going to have to put this in brackets. So I power the whole fraction to the power of 23. And we get 0. Let's write this down, 0.046. Remember, 4 decimal places normally for this 1, 2, 3, and it's 4, 6, and there's a 3, 6, so let's call that 4. So 4 dp. Now what we need to do is to compare this with our significance level. So we have 0.0464, which is less than our significance level of 5%. So if it's less than 5%, or it's less than our significance level, remember what that means is we are going to reject H0. It's almost saying like H0 is unlikely because it's less than that significance level. Now always write down your conclusion once you've written down whether you accept or reject H0. Don't just leave it like that. And all you need to do is look back at the question and almost like copy down the information that's there. Now what we're asking us to test, whether there is any evidence to suggest the company is overstating the proportion. So we just need to say, yes, there is evidence, or there isn't evidence to suggest the company is overstating the proportion of the packets of crisps stating a price. So since we reject H0, all we do is like basically answer that question, and we would say there is evidence, because we're rejecting H0, that the company is overstating, so just copy it straight out as it's written, the proportion of packets containing the price. Okay, there's a lot to read in this question here. It says an electronic company makes small components for use in computers. It claims that the percentage of defective components coming off the production line is 0.05, so 5%. The electronics company sells the components to a retailer. The retailer suspects that the percentage of defective stated by the electronics company should be higher. From a very large consignment recently purchased, the retailer tests the components until he finds a defective component. There's the geometric distribution hint, until he finds a defective component. He finds a defective component on the 90th component that he tests. Is there any evidence to suggest the retailer's suggestions are correct? Test at the 5% level of significance. So there's all the key information highlighted. So if we go back to this bit here, they suspect it should be higher. So the retailer suspects that the electronics company is understating their claim, that they're actually saying it's lower than what it really is. That will help us when we decide on H1. So H0, now we need to be careful that 0.05 is a percentage, not the decimal. So I'm actually going to write it as 0.05 and I'll put the percentage here. Now since they suspect they are understating the claim, they think the percentage should be higher than 0.05%. Now remember what that means. If it's greater than, we actually do a lower tail test. So when you do this question, you might want to write down that, and to remind yourself that on this it's a lower tail test. We need to state what X is, and this is going to be the number of, now what are these, components tested until a defect is found. Till a defect is found. So now we know that this is our random variable X is a geometric distribution with 0.05% success. And because we are doing a lower tail test, it means that actually we're going to be working out the probability that he will find a defect in less than 90 components. So we can use the formula. So I'll write this down. Probability that x is less than or equal to x is equal to 1 minus p to the power x. So we can just substitute the numbers in and work this out. So it's going to be 1 minus, now we now need to put the decimal in. So 0.05 divided by 100. Let's change that to a decimal because it's 5 times 10 to the power negative 4. So 0.0005 to the power x, and in this case x is going to be 90. Yeah, so you just plug that in. So this is going to be work this out in the calculator. So 1 minus 0.0005, so we need to be careful typing that in, to the power 90, and what we get is 0.044. Now we get 0.1, so that's 0 there, so that's 4 dp. We now compare our calculated probability with our significance level, which is 5%, so that's going to be 0.05. We can see what we've calculated is less than 5%, which means that we reject H0. There's a low likelihood of that happening. It's lower than our significance level. And then the last bit is just copying out basically this. We answer this question: is there evidence to suggest that the suspicions, the retailer's suspicions, or the suspicions retailers, are correct? And we just write down there is evidence to suggest the retailer's suspicions are correct. Suspicions are correct. So we just answer that question. You should now be able to do exercise 4C on pages 68 to 69. So remember, if you see questions like until he finds something is done. So if there are no fixed trials, okay, we basically do something until we get success. So trials until we get, or in the question they get success. We know that's going to be a geometric distribution. When we want to work out probabilities, we can use these formulas to help us. This. And if it's the probability that it's less than x, it's going to be this. And if it's greater than or equal to x, it's going to be this. Now, unlike previous distributions that we've done before, if h1 is where it's less than, we do upper tail test, which actually means you're going to be using this formula here. If we have h1, it's probability it's greater than something, we do a lower tail test, and I explain the reasons why that's the case, because the mean is 1 over p, and as one goes up, the other goes down, reciprocals of each other. So we'll actually use that one for a lower tail test.